Buenos días, os presento la conferencia de hoy que está a cargo de Mehrdad Hejazi, profesor de estructuras tradicionales de la Universidad de Isfahan, de Irán, y nos va a hablar de la arquitectura patrimonial construida con tierra en Irán, desde el punto de vista de la construcción, de las técnicas constructivas, los materiales empleados, pero también la degradación, las posibles ventajas, posibles caminos de recuperación y de sostenibilidad. El profesor Hejazi es experto en estructuras tradicionales, en estructura histórica y además investiga en formas y técnicas de recuperación de la arquitectura tradicional, de tierra y de otros materiales, a nivel estructural y también en zona sísmica. Bueno, pues os dejo con la conferencia y muchas gracias.
I'm going to explain about heritage earthen buildings in Iran. First, I give you introduction, then explain about adobe making, then construction technology, then elements of sustainability, and then characterization of Persian adobe, and at the end, damage to adobe and protection methods and conclusions. There is availability of clay in Persia, and use of sun-dried molded mud has been in process since the 6th millennium BC. The Bam Citadel, with the area of over 200,000 square meters, is the largest adobe complex in the country, and also the UNESCO Historical District of Yazd, which was registered in 2017, is totally made of adobe. As you can see here, some buildings inside the UNESCO site in Yazd in central Iran. To make adobe, usually they mix soil with water and leave it for a few days, 2 or 3 days, and the combination of the clay, it's about 30 to 40% clay and also the soil, and sometimes a portion of straw is added to the mixture. Then they leave the water and soil for a couple of days, then mix them, then mold them by hand, and then place the adobe blocks vertically for drying. As you see here, to the left, it's the wet adobe taken from the wooden mold, and then make it vertical for a few days to dry. And this images shows you how they make the adobe. And this is a movie taken in Bam in 2017 when it was restored after the earthquake in 2003. This is the traditional method they use to make adobe. And also here you can see how after 2 or 3 days how the material is put into the mold, and it's quite a difficult work to do that. It needs experience, as you see here. The construction of foundation, I'm going to explain. The foundation is usually lime concrete. It is lime wash, about 200 kilogram per cubic meters, and 25% of clay, and also sand gravel, and also they use vertical narrow stones for connection to the wall, which is going to be constructed later. Here you can see the details of the foundation in Kerman in Iran, and also here you see the stone dado in order to protect the main adobe wall from rain or water. Here you see the construction of adobe wall. It is constructed on stone dado. Some wooden vertical posts are put or inserted inside the wall, and also some wooden horizontal beams are used, and at the end the roof is constructed. Here you can see how in BAM they used to construct the wall, and this video shows you how they do it with very simple materials in order to make everything in order. The mortar is mud, and before putting the adobe on place, they put it inside water in order to absorb some water, and then they put the adobe block on the mud mortar. This type of construction is itself an intelligent, an intangible heritage that master builders have kept since many, many centuries, and still the same process is going on in the citadel. Then we go for the lintel. As you see here, arched adobe lintels are usually constructed over the openings such as doors or windows, and to do that they use a gypsum form which is placed on supports which could be brick or stone, as you see the detail here, and there's a shoring here in order to support the weight of the construction. There are two types of floors. One type to the left is lime concrete floor, which is directly made on the soil, or in some constructions a wooden floor is used with these details, as you see here, with the distance above the ground in order to prevent moisture. Also, to construct some types of walls, they use pise or chine. As you see here, it is rammed earth and usually used for large and tall walls. These are the remaining of some walls after the earthquake in the BAM citadel. And as you can see, they have shown a good performance. They are not completely deconstructed, as you see, and it is because of this gaps between different layers that has been able to dissipate the energy of earthquake. And this is the traditional method. They put the first layer, and then they put the second layer, and between the layers usually they use some parts of plants in order to make a distance between two layers. As you can see here, to the left is the damaged China wall after the earthquake, and to the right it is the repaired wall. And as you can see here, the performance has been very good and satisfactory. For the roof of for the roof of adobe buildings, there are two types. First is a wooden roof when they need a flat roof, and the other type is adobe roof when they would like to have a curved roof. First, we explain about the wooden roof. As you see here, to the right, you can see a traditional house belonging to 4 centuries ago, and in the left, you can see that wooden tie beam is put on the top of the wall, and then secondary beams are put on the main beams, and some additional materials such as mat, compacted marl, soil plaster, and at the end mud straw mix is put on the top. Here the roof functions as a solid diaphragm against horizontal forces, and also, as you can see here, it has a very good heat insulation properties. Here you see the different details and different parts of a roof and other details. Sometimes we use adobe roof if the roof is made of adobe. It can't be flat. It should be curved, and it could have many types, such as spherical vault, quadripartite vault, and so on, that I'm going to explain each. For a spherical vault, as you can see here, adobe break courses are put in a circular manner, and this is one to the left which has been constructed. The other is a quadripartite vault from 4 corners of the plan. They start constructing the vault, as you see here. And also the other is the groined quadripartite vault. As you could see here, we have longitudinal adobe courses, and here we have transverse adobe courses. And the figure at the bottom and in the middle shows different types of this type of adobe. Now we have the barrel vault. As you see here, its construction starts from the supporting wall and then comes towards the other end, and the middle image shows the final situation. Here is the steps of making adobe vault. As you see here, usually they use a gypsum form at the beginning, and then they add the adobe blocks here. And in order to adjust the work to keep the shape, they use adjusting ropes, as it is shown here. And then we have ribbed vaults. There are 4 ribs in 4 sides, and the main vault is constructed on 4 ribbed vaults. In order to make a rib vault, first they need to make the rib, which is an arch, and usually they use gypsum forms as you see here, and this is in the BAM citadel during reconstruction works. In order to make the gypsum form, they should first make it on the ground according to the shape, geometric shape they need. They put bricks in two sides, and in between they pour gypsum, and then after drying you have the gypsum form as here, and also sometimes you add some reed inside in order to reinforce it. As you see here, these are the breaks in two sides, and then they put or pour gypsum mortar inside, and also wooden reeds inside in order to reinforce them. And to the left you see the constructed gypsum forms, and to the left is a form in a room after the earthquake. And here you see the forms which are installed in order to put to adobe blocks on it. And here you can see the ribs which are constructed. This animation shows you how the gypsum form is made in BAM citadel. It is, and these are the materials. It is reed, and also we have the gypsum and water. And these are the result of the work. And here you see that gypsum mortar is already put inside, and then reeds are inserted in order to add tensile strength to the form, and this is how they make the mixture and pour it in the mold. Now let's go to the elements of sustainability of adobe, why we use adobe. One reason is high thermal capacity of earthen materials, especially in warm and hot, dry lands. The other is the compact plan of the building with blind external openings. It is a method we use in Iran, and by this we enhance the sustainability of the adobe construction. Here to the left at top you see the dense plan of houses in Yazd and in other cities near Yazd. Also the minimum exposure of surface to the sun, as you can see here, the domical roofs creating shadow on the roof, and also white surfaces of the walls, and also the roof reflects the sunshine, and in the desert, in hot region, it helps to reduce the temperature. The other elements we use here is a central courtyard with a pound of water inside and small gardens around, which makes a pleasant microclimate inside. The other is use of wind towers in some buildings, and using a wind tower would make a pleasant air circulation inside the building and makes the temperature cool and very pleasant, and it is possible to show that the direction and also the height and the other factors are effective on the functioning of the wind. And as you can see here, this is the mass flow of air when you have different angles for the wind towards the wind tower, and also it is the effect of the wind velocity. For example, when the velocity is maximum, the mass flow is maximum, and also when you have an angle of about 45 degrees towards the wind tower, you get the most effective work. And when you have sometimes 19 degrees of this angle, you have negative mass flow, and it works as a ventilator, which is used or useful during the night, that you can get the air from the internal micro climate, which is very nice, as I explained here, and the cool air goes inside the houses and gets away. And also there have been some efforts to characterize, to do characterization of Persian adobe from different viewpoints. As you can see here, sometimes you see some cracks, or sometimes there are some traces of damp inside some houses, adobe houses. If we want to have a look at the results of some scientific works on the material properties of adobe, you can see here some results from some experience on old and original adobe materials, and also new adobe which are used for construction. Here you can see the mechanical tests have been done, and here as you can see, we have two types of adobe for dry and wet adobe tests. As you can see, even we have the compressive strength of about more than 6 megapascal for some sort of adobe, and also for flexural strength, even we get strengths of more than 2 megapascal, as you see here, and also the modulus of elasticity could be up to more than 300 megapascal. Here it's a interesting comparison between dry and wet, I would say previously wet adobe samples in a basement, and here you see that the adobe, which was previously wet and now is dry, has a higher compressive strength. And it is somehow interesting that how adobe, after you get in wet and then drying again, can increase its strength. Also here we have the stress-strain relationships or graphs for traditional old Adobe and new Adobe. And also if you do some petrography and soil test on the materials, you can find out what the elements of the materials are. If you want to have a look at the damages that may occur to Adobe and how to protect them, for the damage we have some water-related problems, wind erosion, vegetation, insects, vermin, and material incompatibilities. For water-related problems, as you see here, you can see coving. It is because of the rain, and also here, in order to solve the problem, usually we use anti-moisture canal or vent canal, which goes along the two sides of the wall. In order to protect Adobe, usually we should repair similar to original fabric. For the mortar also, when we are patching, like here, we should replace it with the same materials. For wooden elements, if you have some wooden elements inside, they should be repaired by wood, not with other elements. For coating, the coating should be the same as before, and we should use the same materials. For the roof, the repairing and maintaining should be with original form and materials, and also for the floors, doors and windows should be the same, and it should be preserved as much as possible. Usually mud plaster, mud straw plaster is used to protect the Adobe wall. Like here, you see the plaster is used, and every year or every 2 or 3 years it is replaced in order to protect the main buildings. If we want to go to conclusions, I should say that sustainable Adobe and Adobe construction has been a human tradition for millennia. It means that its history is as long as the history of human. 2, it is important to keep the traditional methods of construction and to use traditional materials for the maintenance of Adobe buildings. We are not allowed to change the construction methods, and we are not allowed to use incompatible materials to restore or to maintain the Adobe construction. As I have explained in number 3, incompatible materials and methods should be avoided. Adobe is one of human achievements that we should keep its traditional production, and also traditional making and traditional Adobe construction. I thank you for your attention.